Now we're asked to find the distance between a point and the line, and there is a formula that gives that distance to us. You're free to use that formula if you're interested. I propose, since we're given the parametric equation of this line, I propose that we use a different formula or a different method to solve this instead of remembering the formula. This is what I'll do. Depending on the t value that we have a different x, a different y, and different z. And for each t, that describes an x, y, z on the line. So for each of those points, we can calculate the distance between a point and another point of the line, maybe p, q, whatever. That will be the square root of 4 plus 4t minus 1. So I'm actually calculating, and maybe I could write this better, actually calculating for each t, calculating the distance between point -1, -2, 1 and point 4 plus 4t, comma 3 plus t, comma 6 minus t. So I'm calculating this distance between this point and this point. So as we know, that will be the square root of 4 plus 4t minus 1 squared plus 3 plus t minus 2 squared plus 6 minus t minus 1 squared, and the square root of that. So if I say f of t is the distance squared, just so I get rid of the square root, the minimum distance it is going to be the distance between the point and the line. And that's because when I'm measuring the distance between a point and a line, I'm looking to measure that distance to the closest point on the line to the given green point there, and not to a point that's far away. So I'm looking for the t value that minimizes this distance, which is the same as the one that minimizes this function there. So I'll just get rid of the square root, as the minimum of the square root function is the same minimum as the function without the square root, and that will be 5 plus 4t squared plus 3, or I should say 5 plus t squared plus 5 minus t squared. I'll take the derivative of that with respect to t. Instead of expanding and then deriving, I just derive it now. That way I don't need to use any special products. So I'll do 5 plus 4t plus 2, or times 4 rather, don't forget the chain rule, plus 2, 5 plus t plus 2, 5 minus t times -1. That's the chain rule together with the power rule. So outside I have an 8 times this on the inside. It gives me 8 times 5, 40, 8 times 4, 32 t, and then plus 10 plus 2t, and then a -2 here on the outside. That's going to give me a -10, and a -2 times t, that's a plus 2t. So grouping t's and numbers together, independent terms together, there's 36t, and these cancel, plus 40. So that would mean that the minimum distance is achieved when the derivative of this function equals 0, which means 36t plus 40 equals 0. So t is minus 40 over 36t. You can divide those by 4, excuse me, if you'd like, top and bottom, to get, this is a plus by the way, to get a 10 over 9, negative 10 over 9t. But then once you plug that back in, that should give you the correct distance. And this distance will be this. It will be equivalent for you if you just plug this t into this function and take the square root. At this point, it's okay if you need to use a calculator. Since we're looking for an exact answer, I'll follow along and I'll say the distance is the square root of, and now I'm using this function on the top there, plugging in t equals to 10/9, and remembering that these two are combining. So basically it's this expression, but with the square root. So that is 5 plus or minus 49 squared plus 5 plus, and now just the negative 10/9 squared, and then plus 5 minus 10/9 squared. So that's the disadvantage of not expanding the equation originally. Plugging in becomes a little bit more difficult, but we can handle it. This times 9, this is a 45 over 9, so that's a 5 over 9 squared plus a, this right here, again 45 minus 10, 35 over 9 squared plus a 45. There was a plus somewhere, right? This was a plus and not a minus, so I'll fix that. This here is a plus instead of a 35. I have a 55 over 9. This other one though is a 35 over 9 squared. So I can just follow along and do 25 squared plus 55 squared plus 35 squared, all of those divided by 9, taking the square root, or excuse me, divided by 81, taking the square root equals 9, right? That's what I get. So I just need to bring this out for 1/9 and then see what the square root of this guy is going to be. This is 25 squared, and I have a calculator. So that's 625 plus 55 squared. That's 32.5 plus 35 squared. That's 1225. Add them all up. That's 48.75, and now I just need to find what's the square root of this. Let's see if that's an exact number. It's a whole number or not. It isn't. It's close to 60. Maybe I could divide that. It's close to 70 actually. I can divide it by 5. And by 5 again, and by 5 again. So I have a 39 times, how many 5s did I use? 1, 2, 3, 3 5s. So 5 times 5 squared, this can come out 39. Still has a 13 times 3, but that doesn't help me in any way, so I'll leave that 39 times 5 inside, which is 195, to get 5/9 root 195, and that's the answer. But again, you're free to use the formula that gives the distance between a point and a line, if that's what you want to do.